Good morning, students. Today class we are going to discussing about the second unit. The second unit is operations on random variable. Operations on random variable. In last classes we are discussing about is a totally the random variable definition and what is the conditions for a random variable. What are the examples we are having for this random variable and types of random variables. Under types, we are going to discussing about discrete, continuous, and mixed random variables. And some of the examples is relating to those types of random variables. After that, we are able to discussing about distribution function and its properties, and density function and its properties, and the relation between distribution and density function. After completion of these all things, we can go for conditional. In that conditional distribution and conditional density function, under conditional distribution and conditional density, we are able to discussing about some of the properties is belongs to conditional distribution and density functions. These properties is also similar to probability, density, and distribution functions. Once you can completing these properties of conditional distribution density, we are going to discussing about the examples of density and distribution functions. Already we are having the main discussion about under discrete random variable, what are the methods we are having for examples of density and distribution functions, and under continuous random variable, what are the methods we are having for examples of density and distribution functions. All are we are discussing in first unit. This complete information is relating to random variable. Random variable. Before that, we are also discussing about some of the properties and rules of a probability theory. This is a completely first unit. Coming to the second unit. The first unit like just you can study about one brick. Already you know that how to forming a brick. The brick is containing a soil and is a black soil, water, and you can add in some of the materials. We can take one shape. After that you can form the brick. Here the first unit is completely belongs to like a brick shape. The second unit is how to using that brick we can build any structure or any building, how to utilizing that and what are the operations we can performing on that brick. The same things we have to discussing in second unit. The first is just like a manufacturing of one brick, and second unit is how to utilizing that brick we can build any construction or any building, that type of things, the similar to our second unit. The second unit is a completely what are the operations we are able to performing on random variable. The first one is we are able to take the expected value. The first one is a expected value of a random variable. Expected value of a random variable. The first concept on a random variable is expected value. Expected value of a random variable. How to finding the expectation value on random variable. And second one is the expectation of a random function. How to finding the expectation value on a random function. And we can able to finding the moments. What is the moments of a random variable? In this moments, we are able to discussing the moment about the origin and the moment about the mean value. The moment about the origin is a one type category, and the moment about the mean we are also calling is a central moment. Central moment. In this category, we are also having some discussion about skew and skewness coefficient. skewness coefficient. After that, we are going to discussing about Chebyshев inequality. Chebyshев inequality. By using this Chebyshef inequality, we can able to finding the fluctuated quantities to exact quantities. How to deviating the fluctuated quantity to the exact quantity by using the mean and variance. Mean and variance. Then you can completing this one, you can move to characteristic function. Characteristic function. We are taken that random variable you can representing in a characteristic function. In that, what are the properties we are having for that characteristic function. Once you can completing the discussion on characteristic function, we can move to moment generating function. Moment generating function. In this moment generating function, we are able to studying about what are the moments we are having for a random variable as well as random function. Once you can completing these two topics, we can go for transformation techniques. Under this transformation techniques, we are mainly having the two types. One is a monotonic transformation and second one is a non-monotonic transformation. In monotonic transformation, already the name is indicating itself. Mono means it's a one-to-one conversion. One-to-one conversion, and non-monotonic is a many-to-one. Many-to-one conversions. We are having the discussion for that. Coming to the first topic in a second unit is a expected value of a random variable. What is the expected value and how to finding the expected value on a random variable? First of all, what is the average? Generally, how to find the average value? We are taking the summation of elements divided by the number of elements. In our probability theory, we can able to finding the expectation value. We must multiplying what are the quantities available in a distribution and what are the probabilities available in the distribution. We can multiplying each and every element with its corresponding probability, and you can make in the summation of this all quantities. We are obtaining the expectation value. Coming to the first topic in the second unit is a expected value of a random variable and random function. Here we are defining the expectation value on a random variable. The average or mean on a random variable is calling expectation value of a random variable. I am repeating the definition for a expectation. The expectation or expectation value, we are defining the mean or average on a probability distribution of a random variable is called expectation value of a random variable. I am repeating once again, the definition of expectation value is mean or average of a distribution of a random variable is called the expectation value of random variable. The expectation we are representing capital E. Capital E. For a random variable, we are writing the expectation capital E of X. Capital E of X is calling the representation of expectation value of a random variable X. Random variable X. Otherwise, you can take in the capital X. Capital X, it is a notation for that. Here, the random variable we are representing capital X and E is representing expectation value. Expectation value. Here, how to writing this finalizer value? Generally, the average value we are finding, the average is equal to sum of elements divided by number of elements. According to the definition of expectation value, here we are able to apply mean or average on probability distribution of a random variable is calling expectation value of a random variable. This one is mathematically we are representing capital E of x. E of x. This quantity we are writing in terms of elaborations. We can take in that. Here I am taking the assumption the x is containing n number of elements. Those are x1, x2, x3, x4 and so on xn. And its corresponding probabilities. Here I am writing the probability of x1, probability of x2, probability of x3, probability of x4 and so on, the probability of xn. And now we can able to finding the expectation value or mean value. We can writing here the expectation value is E of x. Otherwise you can gain the notation is x bar. In some cases or some of the textbooks is giving the notation is x bar or expectation of x or the mu of x. Either any notation is given the representation of the mean value or expected value. For these quantities we can writing the expectation value is x1, its corresponding probability is x1, it's a probability of x1, plus x2, the probability of x2, plus x3 and its corresponding probability is the probability of x3, plus and so on. You can write in the finalizer value is probability of xn into probability of xn into probability of xn. This is a representation for finding the expectation value for a random variable. Here we are having the mainly two types of random variables. Totally we are having three types. Among those three, we are only discussing about two. Those are discrete random variable and continuous random variable. For discrete random variable, what is the expectation value formula? We are having the expectation value formula is E of x. One is a E of x. E of x is equal to summation of I is equal to 1 to n the xi into p of xi. This is the formula for discrete random variable. In this one, E of x is representing the expectation value. The expectation value of a random variable capital X. This one is giving the summation. The summation range is I is equal to 1 to n. Here what you can write in here, just you can multiply the x1 element with its corresponding probability plus and x2 element is multiplying with is the corresponding probability plus x3 element is multiplying with corresponding probability. We can repeating this process up to how many elements can be existing in experiment. Here the discrete random variable is having the collection. The collection is from x1 to up to xn. Those elements we are writing in a summation symbol. The summation symbol is range is I is equal to 1 to n. Here n is the natural numbers. The range we can representing I is equal to 1 to n, and what is the elements we are having in that? Those are xi into the probability of xi. Xi is the element and the probability of xi is representing the corresponding probability. This is the formula for discrete random variable. Directly we are using that. We are using that one, can able to finding the expectation value when random variable is discrete. Coming to the second one. The second one is when random variable is continuous, what is the expected value? For continuous random variable, we are having the expected value E of x. E of x is equal to integral minus infinite to plus infinite x into fx of x into dx. X into fx of x into dx. Here you can simply remember, you can take neither discrete or continuous, the functions are same. in case of continuous, you will consider integration. In case of discrete, you will consider summation. You consider summation. In case of discrete random variable, the expectation value is containing the summation symbol. The range is I is equal to 1 to n xi into the probability of xi. In case of continuous random variable, we are able to consider the density function. In this density function, we are representing u of x is equal to integral minus infinite to plus infinite x into fx of x into dx. Here fx of x is representing the density function of a random variable. Just you can multiply with element. What is the element we are having? That element is multiplying the density function. When out to saying that continuous, just you can keep the integration value. And now to take in the discrete, we can take in the summation. Is only the difference. In case of discrete, we can take in the summation. In case of a continuous random variable, we are taking the integration. But coming to probabilities, in case of discrete, we are taking the probability value. In case of continuous, you can consider the density function. Is a small fx of x. Coming to the random function. Up to now we are seeing that random variable. The random variable means just you can representing capital X or capital Y or capital Z. These are random variables. These are having the expectation value like this. Suppose the random variable you can representing in terms of function. In terms of function, how to finding the expectation value? How to find the expectation value? When now to consider the functions, the functions also we are writing same what we can writing for a random variable, same thing you can writing for a random function. There is no change here. You can see that for writing a expectation value for a discrete random function, the formula is expectation of x is equal to summation I is equal to 1 to n, the g of xi. Here g of xi is representing random variable function into the corresponding probability. What is the probability is having? You can multiply that quantity. Either function or variable, it must have its corresponding probability. Those two quantities we are multiplying. How many quantities we consider? Based on the sequence. Based on the sequence or a collection of elements, we can treat in the entire combination. This one is for discrete random variable. We can move to continuous random variable. In case of continuous random variable, we can take in the integration symbol. Integral. Here we can writing for a continuous random function. For this continuous random function, what we can writing here? Already we know that. For a continuous integration, for discrete, we are having the summation. For continuous case, expectation of x is equal to integral minus infinite to plus infinite g of x into fx of x to dx. In this one, the g of x is representing the random variable function and small fx of x is representing the density function. Just you can multiply these two quantities, you are able to finding the expected value on continuous random variable function. Suppose we can take in the conditional expectation. The conditional expectation means we are additionally taking the conditional event. Here I am taking the conditional event is B. B is a conditional event. For this conditional event, I am writing the expectation is E of x given B is equal to the changes occur where density function is there. That's why I am writing integral minus infinite to infinite x into fx of x given B into dx. A is given the conditional density function, just you can keep that. You can simplifying this entire thing, we can obtain the conditional expectation value on random variable. These are the basic formulas we are having